Welcome to the demo for the upcoming New Horizon Milestone 1.1 delivery and upcoming testnet release. In this demo, we're going to walk through the New Horizon protocol and show some hands-on examples. So we'll start here in the New Horizon technical specification. You'll find a lot of details describing the protocol, and the purpose of this document is for internal alignment and to act as a foundational blueprint for the project moving forward. So everything from architecture diagrams to descriptions of the components. The core of the New Horizon protocol is made up the main chain and the proof submission interface. So just to begin, the main chain is a standard layer 1 blockchain. It's based on Substrate, and its main responsibilities are to receive proofs, verify them, and store them in blocks, and make the verification available for other parties to see if their proof was verified. And number 2 here being the proof submission interface, which is the interface by which these parties are able to submit the proofs. So these represent the changes that were made to the main chain and the new transactions that were added. So just a note here, these two pieces represent the core of the protocol, and there are a lot of creative use cases that can be built on top of the protocol from there. But before we dive too deep, we can think about the main chain as being able to handle this functionality for verifying proofs, but it's also a standard blockchain which can send and receive tokens as well. So just as a quick example, we can show that in action. Let Chrome extension, and we can see here that I'm connected to the New Horizon main chain on the internal testnet. And we can see here, if we go to manage networks and we type NH testnet, I have it included. And the main currency here is NZen. And this is the native gas coin. So if we see here, I have a balance of about 850. So I'll go ahead and send some tokens to my secondary wallet. I'll send 100. And we have about 6-second block times on the main chain. So that has been submitted to the network and it looks like it's complete. If we go over here to the work, which we have deployed pointing to testnet, we can see 16 seconds ago during this block, there was a call to the balances module. So this is just demonstrating that this proof verification chain also has the ability to transfer balances the same way any other layer 1 blockchain would be able to. And since we had it up, this is just a quick view of the block explorer up and running on testnet for the main chain. And the proof submission interface is essentially the set of commands that are exposed by the New Horizon main chain or the proof verification chain. So the first one being the ability to submit a proof. This allows external parties to submit their ZK proof to the network along with its public inputs, and our internal Flonk native verifier will go ahead and verify the proof and include it in a block. The other RPC command that's exposed is this proof path, and this is known as the proof of existence endpoint. And this is the endpoint that external parties will call when they would like to be sure that their proof was included in a block. This does complete the protocol in the sense that we now have the capability to submit proofs to the network and see that they were verified. So naturally, that creates just a few potential simple examples for what could be done with the network. So this could be a ZK app that's producing a proof, or some other means that a ZK proof is being created. That entity has the ability to submit their proof to the New Horizon main chain. And once they see it included in a block, it can be understood as final that their proof was verified. So even at the simplest level, we have a full-fledged protocol that is able to verify proofs. Next, we can talk about the attestation mechanism. Now, so far we've learned that the New Horizon main chain is verifying proofs, and every X number of blocks, according to a policy, all of those proof verifications are rolled up into a Merkle tree and a new Merkle root is created. Now, our New Horizon attestation mechanism will take that Merkle root and be able to submit it to a smart contract on Ethereum. This becomes particularly useful to an L2 rollup use case, such as the Polygon CDK, where now New Horizon has the ability to insert itself into the modular stack as a proof verification layer, similar to a data availability layer like Celestial. Now let's take a quick look at what that example could look like. So here we have a Polygon CDK instance that our team has deployed. Now this CDK instance has been modified to be able to insert New Horizon as a modular proof verification layer. And that has been done by making changes to the internal Golang code and also to the Solidity code related to the smart contract functions. So right now I have my MetaMask connected to the layer 2. And as you can see, I just sent a transaction of sending 10 tokens from one wallet to another. Next, what would happen is you'd be able to see this transaction on the Polygon Layer 2 Explorer, which our team has deployed. So next, we would be waiting for the Layer 2 prover to create its proof and eventually send that proof to the New Horizon main chain. So back at the main chain Explorer, if we scroll down, we can see that there's a block here with a second transaction included. And we can see that this block includes a call to the settlement flonk palette, which has the submit proof function that we learned about earlier. So just to examine this a little bit further, this is a proof that's coming from the Polygon CDK. And we can see that that proof is being verified and included in a block. So now that our proof has been verified on the New Horizon main chain, we know that that proof will eventually be included in a Merkle tree. And now what's going to happen next is the Merkle root of that Merkle tree is going to be sent to our New Horizon smart contract, currently living on Sepolia testnet. And that transport is happening by means of a relayer, which is watching the New Horizon main chain for any new creations of Merkle roots. And that Merkle root, again, is being submitted securely to the New Horizon smart contract on Sepolia testnet. Now, just a note, right now, we did not verify this contract, which means none of the method signatures are legible, and that's done just for license purposes. But you can see that every 10 to 12 minutes or so, there's a new attestation that's being completed on Sepolia testnet. Switching over to the Polygon CDK smart contract, we now can complete the puzzle. Initially, the Polygon CDK sent its proof to the New Horizon main chain. The New Horizon relayer sent the attestation to our New Horizon smart contract. So now the latest proofs have been verified and exist in the EVM state. Now the Polygon CDK smart contract has the ability to verify that their proof from their latest batch was included. And that is done by means of fetching the Merkle proof from the New Horizon main chain, which is done by that proof of existence endpoint that we learned about earlier. Now that it has the Merkle path, it can send the Merkle path along with its attestation ID and allow the New Horizon smart contract to confirm that the proof for that batch for the layer 2 has been successfully verified by the New Horizon main chain. And that concludes the cycle. So in summary, we've examined some of the core components of the New Horizon protocol, and we've seen some simple and complex examples of how the New Horizon protocol can be inserted into different application flows. One of the most interesting being the modified version of the Polygon CDK, which our team has deployed. Here we see some documentation that has been created, which is a great learning resource to continue to learn more about the protocol. Thanks a lot for watching.